From tech insights to space exploration, it's a journey of discovery. Unleash your curiosity with Astral Advent, your gateway to the universe. Have you ever wondered how programming languages evolved over time? It's a fascinating tale, filled with innovation, breakthroughs, and a whole lot of genius. Programming languages, the lifeblood of our digital universe, have been instrumental in the evolution of technology. They've transformed from cryptic codes understood by a select few into accessible tools that empower millions to create, innovate, and change the world as we know it. Just imagine, once upon a time, we were punching holes in cards to communicate with machines. And now, we're building complex virtual realities and intelligent systems. It's a thrilling journey, and we're just as excited as you are to delve into it. We are about to embark on a fascinating exploration, a journey through time and technology, tracing the evolutionary footsteps of these remarkable tools of creation. So, buckle up as we time travel through the intriguing world of programming languages. Our journey begins in the dinosaur age of programming languages with FORTRAN and assembly. These are the trailblazers, the pioneers that started it all. Imagine the wild west of the digital frontier, with these two as the early explorers carving paths into uncharted territories. FORTRAN, the first high-level language, was developed in the mid-50s by IBM. Its name, a contraction of formula translation, hints at its primary function: to make programming more accessible, moving away from the cryptic machine-level code. It brought about a significant shift, allowing scientists and engineers to write programs that were both efficient and easier to understand. Assembly, on the other hand, is a low-level language, a step above machine code. It's like the grittier, hands-on cousin of FORTRAN. Working with assembly meant dealing directly with a computer's architecture, making it both powerful and demanding. It was a language that gave you control, but with great power came great responsibility. However, both FORTRAN and assembly had their limitations. FORTRAN, while easier than machine code, still had a steep learning curve, and assembly was just too complex and specific for widespread use. These languages were not without their challenges, but they played a crucial role in the evolution of programming languages. These early languages laid a solid foundation for the advancements yet to come. They were the stepping stones, the building blocks that paved the way for the high-level languages and diverse programming paradigms we see today. As technology advanced, so did the complexity of tasks, leading to the rise of high-level languages like COBOL and BASIC. With these languages, programming took a giant leap forward. COBOL, or Common Business-Oriented Language, made coding more business-friendly, simplifying data processing tasks for corporations. ALGOL, on the other hand, was a scientific language, setting the stage for many languages that succeeded it, like Pascal and C. But it was BASIC, beginner's all-purpose symbolic instruction code, that truly democratized programming. It was simple, easy to learn, and it brought programming to the masses, from school kids to hobbyists. These high-level languages made coding less about understanding the machine and more about solving problems and creating solutions. These languages were more than just tools. They were catalysts sparking a revolution in the world of programming. They made coding accessible, and in doing so, they opened the door to a new era of innovation and creativity. These languages turned a new leaf in the programming world, making way for the C era. Enter C, a language that would forever change the programming landscape. Emerging in the early 70s, C was a game changer. It was like a Swiss Army knife for programmers, versatile and powerful. C introduced a new level of control, allowing programmers to manipulate hardware directly. This made it the language of choice for system programming, and it's no surprise that the Unix operating system was rewritten in C. One of C's most significant contributions was its syntax. It was designed to be simple, yet expressive, making the code easy to write and read. This syntax has influenced many modern languages like Python, Java, and C++. But C wasn't just a language, it was a philosophy. It championed the idea that programmers should have unlimited power over their code. This ethos has had a profound impact on how we program today. The C era paved the way for a paradigm shift in programming, the object-oriented paradigm. With the advent of C++ and Java, the programming world embraced object-oriented programming. This marked a groundbreaking shift in the way developers thought about software design. Instead of focusing solely on tasks and procedures as earlier languages did, object-oriented programming, or OOP for short, encouraged developers to think in terms of objects entities that encapsulated both data and the operations that could be performed on that data. Let's take a quick stroll down memory lane. The year was 1983, and a new language named C++ entered the scene. Designed by Bjarne Stroustrup, C++ was an extension of the C language, but with a twist. It introduced the world to classes and objects, creating a new way to structure and organize code. Suddenly, programmers could create more complex, yet manageable applications. But the OOP story doesn't stop there. In the mid-90s, Java made its grand entrance. Java took the OOP paradigm to a new level with its write once, run anywhere principle. This meant that Java programs could run on any device that had a Java virtual machine, making software more portable than ever before. These languages, C++ and Java, along with the OOP paradigm, fundamentally changed how we develop software. They gave us the tools to write code that was more modular, more maintainable, and more reusable. And this, dear listeners, was the dawn of a new age in programming. While OOP was revolutionizing software development, another revolution was brewing: web development languages. The birth of the internet brought about the need for a new breed of languages: HTML, CSS, and JavaScript. HTML, or hypertext markup language, came onto the scene as the backbone of web content. It gave us the structure and semantics to make sense of the wild, webby world. But a skeleton without skin is, well, a bit bare, isn't it? Enter CSS, or cascading style sheets. It's the designer of the bunch, adding color, style, and layout to our HTML skeleton. And then we have JavaScript, the magic behind the interactive elements on the web. It's like the puppet master, making things move, react, and work seamlessly in the background. Together, these three musketeers of web development languages transformed the internet from a static, text-heavy platform into the dynamic, interactive universe we know today. As the internet evolved, so did programming languages, leading to the rise of modern languages and paradigms. Newer, more powerful languages like Python and Ruby emerged, along with shifts in programming paradigms. Suddenly, the tech world was introduced to Python, a high-level interpreted language known for its simplicity and readability. With a syntax that emphasizes readability and reduces the cost of program maintenance, Python became a popular choice for developers globally. Then came Ruby, a dynamic open-source programming language with a focus on simplicity and productivity. It has an elegant syntax that is natural to read and easy to write. Ruby was designed to make programming fun, and it continues to hold a firm place in the hearts of developers. Meanwhile, functional programming started gaining traction. This paradigm treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It offers a whole new way to think about solving problems and building software. These languages and paradigms are shaping our present, but what about the future? The future of programming languages is as exciting as its past, with artificial intelligence and machine learning playing pivotal roles. As we advance into the future, we see a shift from traditional programming paradigms to more intelligent and autonomous systems. This shift is largely driven by the rapid advancements in AI and ML, shaping the way we interact with technology and how technology interacts with us. We can anticipate more programming languages designed specifically for AI, ML, and data science. These languages will likely be more intuitive, efficient, and flexible, enabling machines to learn, adapt, and make decisions. Just as COBOL and BASIC opened up programming to a broader audience, we can expect future languages to democratize AI and ML, making them accessible to everyone. The future is full of possibilities, and it's thrilling to imagine what's next in the world of programming languages. Well, that was quite a journey, wasn't it? We've navigated through the labyrinth of time and technology, starting with the early pioneers like FORTRAN and assembly, which laid the groundwork for future innovations. We then climbed to the heights of high-level languages like COBOL, ALGOL, and BASIC that made programming more accessible. Next, we dove into the era of C, a language that has left an indelible mark on modern programming practices. From there, we journeyed through the realm of object-oriented programming where languages like C++ and Java revolutionized software development approaches. We surfed the waves of web development with HTML, CSS, and JavaScript, shaping the internet as we know it today. Then we explored the modern landscape, home to Python, Ruby, and functional programming, embodying recent trends and innovations. Finally, we peered into the future, speculating on emerging languages and the role of AI and ML in shaping what's to come. We hope you enjoyed this ride through the evolution of programming languages. Don't forget to share your thoughts and favorite programming language in the comments below. Until next time, keep coding